Hi, this is Karen O'Brien, and I wanted to show you how to create an animation of flood maps. So animated flood maps, we're going to just try to walk you through this process. So the first thing that you need to do is to make an animation run. And in order to do that, you need to set up the control parameters. And let's just take a look at these properties. This would be a 4-hour simulation, and it's set to detailed graphics. I don't recommend that you use detailed graphics because it slows your modeling down. But so I recommend text screen. Output interval is 0.1. Update interval, graphical update interval is 0.1. And then down here under time lapse, you'll want to set this to 1 because you want to get this file timdep.out. And this output interval cannot be lower than this output interval. I mean, maybe it can, I just never tried that. And you'll want to be sure to uncheck this. Then you'll click Save. And the next thing is to export and run, which I have already done. So you can see here that this is the exported file. Let's quickly look at cont.dat. So you can see that it is 4 hours at 0.1 output interval. This means detailed graphics, and this is your graphical update. You don't really want to run models with detailed graphics because it makes them run really slow. But this one does it just for the sake of the class. Then this is the time-lapse output. The switch is 1, which means timdep.out, and the output interval is 0.1. And then when you run the model, you'll get this file called timdep.out right here. And it's not that big, but this file can get really big. It can be gigabytes of data. So I recommend that you are just, careful. If you want to use timdep.hdf5, that might be preferable. But timdep.out gets you a little bit more data and details when you load the map into the mesh tool. So the model is finished and complete. So the next thing to do, first of all, I'm going to click Save. Okay, and I'll turn this off. So the next thing to do, first of all, let's set up our map. Let's set up our project area. So we won't need this or this, and we don't want our boundary condition on there. We don't want that boundary condition polygon, so I'll uncheck that. And we don't necessarily want to see our grid. Sometimes you want to see your grid, sometimes you don't. Let's just turn it off, and let's change our comp domain a little bit. So I'm going to double click the comp domain and go to symbology, and then I'll go to simple fill, and I'll change this, I'll change this to no brush. So that way we still get the stroke color, but we don't get the brush. And I'll click apply and OK. And you can see that this is the extent of our computational domain. Now we will want to let's see, computational domain. The next thing we want to do is to load the mesh data because that's the result. So let's do this. Let's collapse this group real quick. And wait a minute, I don't think I want my satellite. Yeah, I don't want my satellite image to be part of that group. And then let's add the mesh data. Let's add this, and this goes to depth.out. Always depth.out because every project has a depth.out. It's going to use more data in here, but let's start with depth.out. Click open, then click add, and it's going to default to our project coordinate system because when we first set up our options, when we first set up the plugin, we go to settings, options, coordinate, and we make sure that this is checked. So if there's any data that doesn't have a projection, it's going to use the project coordinate system. And then of course we'll want to put this down on the bottom, and this is your bed elevation, as you can see from this guy right here. And also note that it has a time control button or icon, so that's important later. Now if we want to modify or review this data, we want to use the layer styling panel. That's this guy right here, layer styling panel. So you can either key F7 or you can click this button right here. And let's just go ahead and dock these two panels together in the same area. And what you get, if you're on the settings tab, what you get is bed elevation. This is time dependent depth, that's why we see nothing. Time dependent velocity vectors, and time dependent water surface elevation. Now, because we use the temp.depth.out, we also get the maximums from depth.out and the water surface elevation maximums. Now, the interesting that this difference in this water level maximums from temp.depth.out is that it doesn't use the whole grid. So if you're using water surface elev.out to do your water surface plots, it gives you all of the elevation, the ground elevation and the water surface elevation. That's kind of useless, to be honest with you, unless you're doing rainfall. So this is your maximum water surface elevation. And then if the time dependent data, let's go ahead and check that out. So this is your time dependent data. Now if you have a Flow2D project loaded, go ahead and close this dialog, because we don't want to use that. We don't want that dialog interfering with our time controller, which is a different size, and that dialog doesn't resize very well, so it kind of pinches this. And then usually when you open this, maybe you haven't done this before, so you'll need to click this button right here to activate this layer. So you'll be clicking this button and it will see that one of these layers has temporal controls, and it'll go find and connect to that layer. And then you'll see that if you click set to full range, this will start at 00 time, and then go to the full range. But you can also control this range in this dialog box right here. And of course our step is either 6 minutes or 6 minutes would be fine. Okay, or you can set it to 0.1 hours. You can do whatever you want. Now if you use this guy and let's start with this one, because things kick off right away. This is a tailings dam tool. This is the tailings dam tool hydrograph to plot this failure. So it's very front-loaded failure, because that's exactly what happened. This particular dam failed, or it's filtered tailings storage. It's not really a dam, but it failed in about 15 minutes, and it failed a total of about 77% of the storage volume became the release volume and failed through this interface right here. So it basically failed everything. And so in the tailings dam tool, we can set this up with the release volume, and we can fail it on a front-loaded pattern with a mud flow parameters and a sediment concentration and a porosity. We can set and configure those parameters in the data files and then fail it and then run that. It's actually an inflow hydrograph that you're running to process this failure. It's just one of the many tools for tailings dam modeling and failure mapping in Flow2D. All right, so now what you can see is the advancement of the flooding at this time. Okay, so you can advance it or you can play it, which is pretty useless. I find that this play button is kind of useless. Okay, so we'll go ahead and pause it, or you can just drag the drag bar. Now you have complete control over the styles of these layers. You can change the colors to blue, or you can change the colors of the arrows and change those to blue or white or whatever you want. You have complete control over the style of these maps. I'm not going to mess with that because you've already seen that in many of my mapping videos and it's kind of tedious. So just leave it as is. Now if you don't want to see the arrows, you just turn them off right there. And if you want to change the, like I would say not the line width, but maybe the length of the arrows, you can do that right here. And they're defined by the min and max velocities, and you can change those right here. Okay. So that's basically how you use the mesh tool, but let's change our focus and let's talk about how you export this as an animation video. So first off, I want to zoom to this layer so that we have our whole project, and then I want to grab a let's see, this is MapCrafter, and I want to create a map layout. So I think what I need to do in order to create a map layout is to set a project path. and that should be here. I'm just going to select this folder, and then I don't think I need to create any maps in order to create a layout. But if you wanted, you could also add your mudflow maps at this time. But I'm not going to do that. I'll just leave that alone. So let's just get the layout. So we'll call this Tailings Dam Tool. And that's the flood results. And then you could put a description. Okay, so we know that this is a 15-minute fail. Let's call that 15-minute TSF fail time. It's not really a tailing storage facility. It's more like a filtered stack. So let's say filtered stack failure. And then you could put some of your mud flow parameters. 0.5 is our concentration by volume. You could put your porosity in here. You could just information maybe about this run. The layer extent is set to grid, and we want to choose one of these map layouts. So I just like this one, so I'm going to choose this one, and then I will, let's see, that's going to put this, I'm hoping that that's going to save this layout right here. So let's just open selected layout, and now it opens this automatic layout that Robson built for this tool. And so you can change this image, and you can change this title, and you can change the scale and the scale bar, and you can change this dialog here and this label down here. You can change the I think these are the grid lines, and so you can change all of these things to kind of suit your project. But that's not what this video is about. This video is about the mapping. So what we're doing is we're going to save this and then close it, and then click cancel here because we don't need that anymore. And now let's go find that layout. It should be, I don't know where that layout went. All right, I don't know where that layout went, so let's just make sure we absolutely have access to that. Let's go ahead and open that layout back up. That's this one right here. And let's go ahead and just do a save as, and let's put that layout. Yeah, we won't put it in Map Crafter. Let's go ahead and put it here. Tailings Dam Tool, TDT Animation, and let's just put it here. Save it, and we'll replace that one. And then now we can close this. So make sure that you just have access to that template, that layout template. That's important. And now we are going to export the animation as a video. So we want to grab a plugin called Crayfish. And Crayfish is, okay, I'm using QGIS version 3.36. And Crayfish hasn't really been modified since like 2021. So what we have is a plugin that is going to act a little temperamental, like a little toddler. So when you click to load it, you might find that the next time you start QGIS, that it just tells you, hey, we can't load this plugin, so we're deactivating it or whatever. So all you have to do is come in here and uncheck it, and then check it again, and click close. And don't worry about the error messages or anything like that associated with Crayfish, because it still works, just a little temperamental. Now, if you look in the mesh drop-down menu, you'll see that you get the Crayfish, and what we want to do is export an animation. Sorry, I always forget this. I have to select this layer first. Now we'll export the animation. And we have the depth layer mapped, so that's what it's going to export. And we'll start with the General tab. This is just my screen resolution, so I'm not going to change that. This is the start of the simulation. This is the end of the simulation. Be careful, because this will start, this could possibly start, this could possibly be wrong. So just make sure that you check this range. 3 frames per second. If you wanted better resolution, you could do 5 frames per second, but I've never successfully modified this and had anything look better. Output file, we need to select an output file. this is, I mean, I've done so many of these, so I'll just grab any one of these and just replace it with, and then we go to the layout. We want to use a custom layout, so let's just navigate to a different layout, and we're going to grab this one right here. And I don't have a label with the ID of time, and I don't even think that works anyway. So unfortunately, I don't think, I've never successfully gotten Crayfish to display the output time. I don't know if that's just me or if it's just Crayfish. We can probably fix that. It's not our plugin, but I think we could fix it. And then we go to video, and I just use high resolution, and this is just inside the Crayfish plugin folder, this file, this executable file. So if you're not in the default system path, just try to, it'll fix it for you. And then this, what Crayfish does is it does a screenshot of all these output intervals, and it does this screenshot, and then it saves all these to a temporary location. But if you want to keep all those images of that flood wave progression, you can just navigate and keep them, navigate and put them someplace you want to keep them at. And then you'll have an image of every one of these time intervals. And then you just click OK. And it starts creating the video. And while it's creating, I'm just going to pause until it's complete, because that's the easiest thing to do. Okay, and I should have started the video right before it completed, and it just says that the animation export was successful. And I'll just click OK. And then you can go to the folder where you did your animation export. And you can see your videos all right here. So let's just sort by date. And this is the video that we just exported. So this goes pretty quickly. So if you want to start it, you know, you might delay the initiation of the failure so that you can kind of see the video and orient yourself before you get the failure, before the failure starts. Or you might want to change the color of the layers, change the color of the maps and things like that. Or you may want to zoom in to a specific area that you want to try to get a better animation for, and then just export the video again. It's pretty simple. And in this case, because it's tailings dam, these videos are not bad. They're pretty small. So that's pretty nice. That's nice for these videos. Only 13 seconds long. So you could slow that down. Maybe if you put it to 5 frame per second, maybe you would slow that down a little bit. Anyway, that's how you export the video. And then Crayfish does one other cool thing. Let's go ahead and open up the this time we'll open up the 2D plot, and let's go ahead and zoom in here to some of these areas. And what we want to do is we want to select the layer of depth, and we'll take time series, and we'll take depth as our group, and we'll do a point. And I think, I'm not positive, but I think you really do have to select all of those things, even if they're already filled out correctly. And then if you put your cursor on a place that has flow depth, you can see a depth versus time profile. Or no, sorry, excuse me, that's not a profile, that's a plot. And then let's go ahead and change our group to velocity, and that would be a velocity versus time plot. So with mudflow mapping, if your velocity goes to 0, that means that this area that retains a depth is that's a cessation of mud flow. That's not going anywhere. So that's like a deposition. So if you put this back to depth and you put your cursor here, you'll see that that depth remains stable. That water is not moving, so that depth remains stable. So that's how you plot and find out. So what do you want to do with a mudflow map? You want to run a mudflow, the tailings dam or the mudflow model until the velocities are 0, and then that final depth becomes your mud flow cessation, and that is your mud deposition. That's how you get that final map. Okay, so now let's see. That was from the point. This thing does one more thing. So if you set this to cross section and you set this to depth and you choose a time, let's do like this, then you can create a profile. Hang on a sec, I might have to do this again. Then this will be from map. Yeah, then you can do a profile at that time. So then if we advance that a bit and we get that same area, that depth should change over time because it is set to the current time on your map. Okay, so that's how you would get a profile of the flow depth from this map. And the final thing I wanted to point out one more time, just because it's nice, is that if you set this to water level, maximum water level, that you get, let's turn these velocity vectors off, you get the maximum water surface elevation of your plot, and it doesn't have the grid elevation as part of the, so if you're using rasterizer and you're trying to plot water surface, it's called WSELEV.out, and you're trying to plot that, it's going to give you a value for every grid element. But if you're doing this mesh tool, it will give you just a value where you get where there actually was water flowing, or mud flow in this case. And that should be the end of the video, so I'll shut this down and hopefully get this posted.